So long story short, there's a lot of interesting stuff going on with web development these days. ASP.NET still is very important for certain scenarios. It's also very important because, of course, you use it for services. The sample I already used with my debugger, that was a services sample, right? Using Web API to build REST services, okay? That, to me, is the number one reason I fire up ASP.NET these days. And .NET Core is really nice for building services like that. And we'll take a look at a very specific scenario for that here in a moment. So that is probably what we use .NET Core for more than anything else. And that we've been using it for a while and been very happy with. And beyond that, you know, again, JavaScript, don't forget that. We all need to know it these days. Now let's move on to a different topic here. Let's talk about containers. Containers are a super interesting scenario. This is actually probably one of the things that I'm more excited about these days than any new technology that's come around in a while. So what is this container stuff all about? Containers are essentially a continuation of the virtualization idea. So when you think back of how all the server-side stuff evolved from the early days of .NET, right? We had individual servers growing into server racks that we had in our data center. And then at some point we started to virtualize things, installing full virtual machines on that hardware, which made it a lot easier to spin up new machines, to scale out. The same image could be used on multiple machines to start up essentially duplicated machines and so on and so forth. And that was a great idea. But it was also a little heavy-handed, right? Because a whole OS is a big image to virtualize. So how many machines, how many virtual machines can you run on one server and still expect them to perform pretty well? But it was a great idea fundamentally, and it's still useful for a lot of things. But when you think that idea further, it's like, how could we virtualize stuff that is smaller, still takes advantage of that same virtualization, it's independent of the other stuff that runs on the same machine, but at the same time it's smaller and only has the stuff it really needs and doesn't include the operating system necessarily. And that's what a container is, right? So it's app virtualization or process virtualization, if you want to think of it like that. So that's the fundamental container idea. And the most important container technology is Docker. Docker has become the de facto standard for containers. This came from the Linux world, right? Docker for the longest time only existed on Linux, and that's how a lot of Linux guys deployed their server-side applications. Well, now Docker is also available on Windows. So that's kind of cool. So you can actually install Docker on your Windows machine and create small containers. And what's nice is you can create containers that are Windows-based, or you can create containers that are Linux-based. So even though I'm running it on Windows, I could have a Linux container right here. And I could then build my app for that. And now I have this container, and I can then deploy this container to wherever I want it to. And I can be assured that that container works exactly the same wherever I deploy it to, because it's a self-contained unit that's virtualized. So no more of that, well, it worked on my machine type of developer speak, right? If the container works, the container works. So now you can deploy that. There's tools around the orchestration of the logistics of that. So you can create failover scenarios, you can create scalability scenarios, and really, really nice stuff. Okay? So that's now available to us. All you got to do is you go to Docker and download it, install it on Windows. Now you get a command line interface, right? Like everything needs these days. So you can start using the command line interface to compose new images. What's kind of cool about Docker is they have this idea of basing new images on existing images. So you can say, I want to do Node.js development, therefore I want some image that's available in the Docker registry that has what I need for Node.js. But then I also wrote this thing that I now want to run, and I have this one other dependency. So let's compose a new container, a new image that's based on the original one, and then just adds these two small things, and boom, here's a new virtual machine almost, right? A new container image that I can then deploy. So that's how Docker works, and you can do that in the command line, and there's compose files that determine how that works. Now what's really cool is that in Visual Studio 2017 we have support for that right built in. Okay? So let me show you something here. So if I go into Visual Studio and I say let's create a new project, I can say I want to build a .NET Core app that's an ASP.NET web app. And then I'm hitting OK, and yeah, that's fine. And now I can say, I want to choose a web API app, and I know it's a little small, but it says down here, enable Docker support, right? And it's actually checked by default. And this adds everything right in that I need to create a Docker image out of this application. Now this requires Docker for Windows to be installed on your machine. If you don't have it, you click that link, you download it and install it. It's just a free open source piece of software, right? So I can then go and click OK, it creates my new project. I actually went ahead and did that ahead of time, so let me open that. Now, depending on how big your containers are and how fast your internet connection is, the first time you compose a container can take a while, which is why I did this ahead of time, right? So what do we have here? Well, this is my Visual Studio solution here. Now, let me make sure that Docker is actually up and running. Yep, it is, right? So this, again, I haven't changed a single character in here. This is just the default template for a web API project. So I have my controller here. Right? Now what's important is this added things like the Docker file automatically. So this defines how these container images are composed. So this says, start out with this image for ASP.NET Core 1.1. This has everything we need to run ASP.NET Core 1.1. Fairly sizable image. I suppose I could have gotten one that's more pointed, but that has everything I need, and it then basically says, use that, add the output of my application, and expose it over an HTTP connection on port 80. So let's just go ahead and let's run this. So I'm going to click the Start button up here, hit F5 essentially. Now note that this actually says Docker. So this has Docker debug support right built in. So let's go ahead and run that. Now what we'll see here in a moment, in a way, will not be very exciting. But how unexciting it is actually the exciting part. So let's see what happens here. So this goes and builds. This does a full Docker compose, builds a Docker image. Docker images can now essentially be seen as the new default deployment unit, right? So rather than creating some sort of exe or an MSI install or whatever you did, now you can just think of this as a Docker, the Docker image as a deployment unit. And here we go, right? So now I browse to this, and you know, here is where it retrieves the value. I can even go and put a breakpoint in here if I want it. Let's refresh that. Okay, and here it hits my breakpoint. And you're like, yeah, what's the big deal? You're running a very simple controller, and you're putting a breakpoint into it, right? We've done that for years. Well, what is the big deal about this here is that this created a Docker image. This Docker image is a Linux-based image. So now my .NET Core app is deployed into a Linux-based Docker image, which Docker for Windows then runs on my machine. So now I'm running a Linux subsystem that serves up a website or a service in this case, that I can browse to from my Windows computer here, and it even takes care of wiring up the debug experience for me, so I never really know the difference. But we are now running Linux right on this machine. And why Linux, by the way? It just turns out that process virtualization in Linux is really efficient. So doing services as Docker containers that use a Linux build is just a really compelling scenario. Now, you could have targeted a Windows build as well, but it's just most people use Linux because it ends up in the cloud, usually cheaper because it's more efficient and so on. So really, really cool stuff here. And to me, it's just amazing how easy it is. Like if you've done this before and you had to manually create these images and then set up the debugging for it and so on, was kind of a pain. So one of my favorite features in Visual Studio, and it's just so easy. Again, encourage you highly to check that out. And also once you start playing with this, look into what you can do with this. Like one of the things that we have done for a long time is the way we build our services, we use Web API. But we usually just build an object that has all the methods that we want to call. And we don't care whether those are hosted in WCF or Web API or whatever. They're just an object with methods. And then we have some config files that say, oh, expose it as REST and JSON. And a few attributes that tell us what's the URL and so on. So we then have a standard build of an ASP.NET Web API app, or a template, right? So they create a new project. Now we hope that all the references are the right ones. And then we add in our DLLs, in the future, .NET standard based. We create a config file, never write a line of code, never add a controller, compile it, deploy it. Well, now with Docker, we can say, let's create an image for that. that Docker image has that app that we need, that pre-built ASP.NET Web API app based on .NET Core. It itself is based on the ASP.NET image, although we probably want a more tailored one that has really only the pieces that we need, not the whole shebang, so it's a smaller container. So then we have that new container, and then we can say, all right, and now add my assembly, my DLL file, and add my config file, and now I have a deployable container. I never need to build a new Web API app. And now I can deploy that to Azure, I can deploy that into my own network, Amazon Web Services, whatever. And it makes for a really, really compelling scenario, easy to scale, easy to do failover scenarios, and so on. So there's a lot of cool stuff there, and I couldn't be more excited about that stuff. So really cool for microservice architectures and so on. And that concludes the containers. In a way, a lot of people are like, what's the big deal, right? It just looks, especially when it works well, it's like almost like it isn't there. But when you really think of the implications, really, really important stuff.